Halogens. In 1842, the Swedish chemist Baron Johns Jacob Berzelius proposed the term halogen for the reactive nonmetal elements fluorine, chlorine, bromine, iodine, and astatine, which occupy group 7 of the periodic table. Each element except astatine exists as diatomic molecules when elements with one covalent bond between the molecules. The term halogen derives from the Greek word halo, meaning salt. This is due to the reactions with metals as they produce a wide range of salts. Halogens easily dissociate into atomic particles and combine with surrounding elements to form compounds. Halogens are generally poisonous. Each has a different level of toxicity as you go down the periodic table. All of the elements produce acids when bonded with hydrogen. They are also poor conductors of heat and electricity. The halogens show trends in chemical bond energy moving from top to bottom of the periodic table column. The reactivity of the element would decrease because of the increasing size of the atoms. Halogens are all-colored vapors. Fluorine is a pale yellow in appearance, whilst chlorine is yellow or lime green. Bromine is a reddish-brown, and iodine crystals are purple hue. The trends in the physical properties of halogens also include the melting and boiling points. The halogens have low melting and boiling points. This is a typical property of nonmetals. They increase as you go down the group. The halogens are positioned in group 7 of the periodic table due to their atomic mass. The number of electrons in the outermost shell is the same as the group number, and the number of electron shells is the same as the period number. The atomic number of an atom is the number of protons it has. For example, fluorine has 7 valence electrons in its outer shell, as do all of the halogens. It has 2 shells, therefore the period number is 2. The atomic number is 9, so the element fluorine has 9 protons in the nucleus. All halogens are electronegative. They gain electrons very quickly, making them the most reactive of all chemical elements. Halogens have 7 valence electrons in their highest occupied energy level, also known as the outer shell, giving them an oxidation number of -1. This is why their chemical properties are similar. In a reaction with metal, a halogen atom gains an electron and becomes an ion with a negative charge, -1. As you go down group 7, the atoms become larger and the outer shell becomes further from the nucleus. The force of attraction between the positively charged nucleus and a negatively charged electron from another atom becomes weaker. As a result, it becomes harder to attract and gain an electron the larger the atom becomes. The more difficult it is to gain these outer electrons, the less reactive a halogen is. Due to their extremely high electronegativity, halogens are not found in their elemental form in any natural environment on Earth. The noble gases consist of 6 elements making up group 18 in the periodic table. These chemical elements include helium, neon, argon, krypton, radon, and inoxidum. Halogens and noble gases are completely dissimilar. Halogens are extremely reactive elements because they need one more electron to gain a full octet of valence electrons, whereas the noble gases are extremely unstable because they already have their full octet and resist forming compounds. Group 18 is arranged in the periodic table according to its boiling point. The noble gases are non-metal, odorless, colorless, monatomic gases with very low chemical reactivity, whereas the halogens include all 3 states of matter and are mostly diatomic.